Green energy is creating a new kind of mineral rush.
So this piece I have here is a very large piece of muscovite, and this is something you might find in pegmatites, which are really coarse-grained igneous rocks.
I recently talked about pegmatites here and why they're so important for crystal hunters, and also something else, rare earth minerals and a source of lithium. Now, lithium is obviously a really important player in the movement to green energy, alternative energies. The push for and growth in the electric vehicle or EV market is often described as explosive, and for good reason. The car market has risen from about 4% to 14% in just 2 years to 2022 and is projected to grow another 18% just in 2023 alone. Plus, the demand for solar panels and the construction of large solar farms all means the need for batteries to store that power, and these batteries are lithium-based batteries, which means more lithium mining or production. But what exactly is lithium? Derived from the Greek lithos, which refers to earth or rock, the lithosphere actually refers to the Earth's upper portion of the crust and mantle. Lithium is an atomic number 3 on the periodic table, and if you remember your chemistry, that means it has 3 protons. Lithium is an alkali metal, which is known for being soft, relatively low in density, and highly reactive. These properties are what makes lithium so useful. And we'll talk about those uses in a bit, but first, where in the world did lithium even come from? Or should I say, out of this world? Carl Sagan famously said, "The cosmos is within us. We are made of star stuff." And this can be taken quite literally. Supernova Nucleosynthesis is the fusion in massive stars that results in the creation of the chemical elements we know. Recent NASA-backed research out of the Arizona State University suggests that most lithium actually comes from dwarf star explosions, noting that while the Big Bang created a small amount of the lithium in the initial formation of the universe, the majority of lithium gets manufactured in the nuclear reactions that power nova explosions. And ironically, one of the key uses of lithium here on Earth is actually in the creation of explosions, nuclear explosions. You probably know of lithium for its use in lithium-ion batteries and the movement to greener alternative energy, but it's also used in the glass and ceramics industry, medications, and even in the past has been used for the manufacturing of nuclear weapons. In 1954, the U.S. was testing nuclear weapons in the Bikini Islands, the first of which was called Bravo, and that used solid lithium deuteride, which yielded 15 megatons or 1,000 times as large as the Hiroshima bomb. The thermonuclear reaction was achieved by the fusion of deuterium and tritium, the tritium resulting from the bombardment of a lithium-6 isotope. So there have been many uses of lithium from past to present, but how do we even extract lithium from our environment in a usable form for these things? Historically, lithium was found and extracted from pegmatites, which are coarse-grained igneous rocks. I just finished up talking all about pegmatites, so if you're interested in learning more about those, check out that recent video. But pegmatites are special because they are a source of unique and valuable minerals, and actually some of those minerals, like lepidolite and spodumene, have been great sources of lithium. But rather than extracting lithium through hard rock mining methods, it's now favored to get lithium via evaporative pools. Because of its solubility as an ion, it can be found in brines. More than half of the world's lithium comes from evaporation ponds in the deserts of South America and places like Argentina, Bolivia, and Chile. This satellite image shows the scale of these evaporation ponds in the middle of the Atacama Desert, Chile. Another great global supplier is the outback. Western Australia is now experiencing what can only be described as a lithium rush. And around the world, there are some other localities that might include some useful quantities of lithium, and this includes Zimbabwe, Brazil, Russia, China, and the US and Canada. In the U.S., Nevada is the leading supplier of lithium, opening up new mines as we speak, and the developer claiming that they can produce 80,000 metric tons a year of battery-quality lithium, leading some energy analysts to call the area the Silicon Valley of lithium.
Also, in the Imperial Valley of California, the Salton Sea is being tapped as a source of lithium, and in fact, some claim it's a massive source. In 1905, local growers were building irrigation canals for the Colorado River water, but it flooded and levees failed. For 2 years, river water poured into the old dry depression and created the Salton Sea. 80 feet and 338 square miles, it became the largest lake in California.
It became somewhat of a famous tourist and celebrity destination, but being a closed system in a desert, the lake was subject to evaporation and it dried up and since has been plagued with a lot of problems, including toxic dust among many. Now it's being eyed for lithium production, with 3 large companies already investing in projects there, including Berkshire Hathaway, Energy Source, and CTR. CTR plans to have its first full-scale facility up and running in 2024 and already has a contract to provide 20,000 tons of lithium to GM. Says the CTR CEO, it could well serve over 600,000 tons a year. However, like all mining booms in the past, we'll just have to wait and see how much the claims match reality. And you may also have heard of one other option for getting lithium, and that's extracting it from seawater. The world's oceans do contain an estimated 180 billion tons of lithium, but getting lithium from seawater has its challenges. While they pool lithium ions via an electrode, it also tends to pull along sodium, a chemically similar element that's about 100,000 times more abundant in seawater than lithium, so it tends to crowd out the lithium. Now, recently, researchers have been able to achieve advanced techniques that can get it down to about a 1-to-1 ratio, but they also noted that this still isn't good enough to make this form of lithium extraction cheaper than the other options. Whatever methods we use to get our lithium, there's going to be some lingering issues. Manufacturers used about 160,000 tons of lithium a year, a number expected to increase nearly tenfold over the next decade. And as researchers noted in the Trouble with Lithium report, lithium scarcity has raised concerns that future shortages could cause battery prices to skyrocket and stymie the growth of electric vehicles and other lithium-dependent products. And while this report was from 2008, there have been similar concerns raised since then. And it doesn't help that there's reports out there that promise infinite supplies of lithium by getting it through seawater, which we've seen has its problems. And even if we get the lithium we need, the other key issue has to do with the environment. All forms of lithium extraction have their issues, from being very water intensive and creating a lot of contamination and waste. Even seawater methods have issues, and both environmental and humanitarian issues are raising eyebrows for the future of a lithium boom. Reports like this one from NPR highlight the issues with child labor in certain areas of Africa. So as you can see, lithium has a lot of uses in our modern world, from being the thing that helped us go to war with each other to being the thing that now promises to help us with our war on climate change.